Hey, so welcome back, and here's another LeetCode problem. So today we're doing one called Pascal's triangle. So all that we're given here is a two-dimensional matrix that kind of resembles more of a staircase. I know they represent it as a triangle, but I just find it more intuitive looking like it this way. And so what you have here is basically the first and last columns are always ones. And so the base case is here. It's kind of the whole array itself, like for row index 0 and row index of 1 here, we see that we're just basically outputting ones. It's not until you get at least 3 columns here that the middle values have non-1 values here, like so. All right, and so basically the challenge here is kind of coming up with these middle columns here, right? So it's pretty intuitive to kind of have the ones at the end. But in order to come up with the middle values, you have to use kind of a formula here that you should be expected to come up with. And so it's basically going to be the current row for the ith column is going to have a value of basically the previous row at index I plus the previous row at I minus 1. So what that looks like here is basically when we're calculating this 2, you're going to look at the cell above it and the cell behind it. Or if you're calculating this value 3 here, you're basically looking at the cell above it as well as the cell behind it. All right, and so that's kind of what's going on here. If you want to actually use a two-dimensional array, you can see here that this is kind of using one-dimensional arrays, current and previous. Using a 2D array would be something like this. So array 2D is basically going to be equal to array, basically this is the current column I, so array 2D, basically the previous or the last row that we've populated at index I, plus array 2D, we look at the previous row and then I minus 1. And so we're basically just going to be appending this result here, okay? And so essentially what we're going to look at here is the top one. So this is going to be kind of a recursive approach in order for us to kind of come up with the previous row. And then the second one here, this is going to be using kind of an iterative approach here. And so this is often preferred because you don't have the same kind of application stack errors that you might get using recursion. So it's often used so you come up with the recursive, more naive approach and then do iterative. This is kind of similar to dynamic programming. We're not really doing any time or space savings here, so there's not really any optimization there. It's just typically you'd want to do this approach in an interview setting. All right, but if you're doing just competitive programming, just given this constraints here, really 33 rows isn't much here, so both of these would work in a competition setting. All right, and so from here, let's go ahead and come up with the recursive approach. And so all that we want to do is basically say that, okay, our current row initially is going to be all ones, just to simplify the first and the last columns having cell values of ones here. And so basically row index plus 1, just because Python is 0 index. And so we're expecting to return this current row at the end here. But with each time we want to get the previous row. And so to abstract that away, we can just say, okay, let's just go ahead and call the recursive call to basically the previous row of it, basically with this size, right? Because it's a staircase design or two-dimensional array, you always want the row index minus 1, all right? And so from here, just to handle kind of a base case or an edge case here, it's basically going to be that, okay, if the row index is less than 2, we just have those 2 base cases where all the columns will be 1 in that case. And so because of that, we can basically just return this current row here. All right, and so let's go ahead and add that like so. Oh, so this is just the base case. But from here, we're going to want to go ahead and calculate the middle columns, okay? And so to do that, what we're going to do is just iterate in the range basically 1, just because we know that the first column is always going to be 1, so we kind of skip over it to do the next index, to basically the row index, just like so. All right, and so that will basically parse or cut off the last column as well. So we just want to say, okay, the current row at index I, and this is just the formula that we came up with before, is basically going to be the previous row at I plus the previous row at I minus 1. All right, so let's go ahead and run that. Looks good. Try submitting. And success. So that basically runs in O of k squared, just because where k is the row index, and we're basically doing a for loop for every single row index here. And then the space complexity is going to be O of k, because, well, we're going to have a application stack of at least row index many, so where k is row index. All right, so that's just basically accounting for this application stack from these recursive calls here. Okay, so let's go ahead and implement the iterative solution now. So we're just going to delete this, and now this is the iterative approach. And so we're going to have basically our response here. And so we're going to return this at the end. And so from here, what you can imagine is that what we want to do is we're going to iterate, and we want to have 2 for loops here. So this is going to be like an embedded for loop. And the inner one is going to actually be iterating over the column. So for I in the range, and because it's a staircase, the number of columns is going to change. And so what you want here is basically the number of columns. And so to get that, we're going to say, okay, we're going to get the number of columns, and that's going to increase in the range of basically our row index plus 1, because Python is 0 index based. All right, and so from here, the number of columns also we want to say is plus 1. And so from here, we're going to want to get the current row, which we're also going to be building from this kind of iterative approach. And that's why these are initially empty. It's because we're in an iterative way, you're kind of building it as you go, while the recursive solution, you're just kind of, you already have the result and you're just calling upon the one that you already pre-computed. Okay, and so from here, we're basically going to be at the end of this, just appending this new current row to our 2D array here. And just because we previously used array 2D when I showed you the formula, we'll just actually replace this here. Okay, and so with that, what you can imagine here is at this point we're going to say, okay, so we actually want to put this here actually, sorry, and then this here. So this is basically computing the columns in the current row. And so from here, we're going to say, okay, if I is 0, or I is the, let me think here, the number of columns, then in that case, we're just going to be appending 1, because that's the first and last column here. And so we have something like this. So we want to say, okay, current.append 1. Otherwise, it's a case where we're computing the middle column. So this is the last or first columns. This is actually the middle columns here. And so to compute this, we just have to say, all right, so then the current, we're just going to be appending array 2D at -1, and then its ith column plus array 2D at -1, and then its I minus 1th column, like so. All right, and so let's go ahead and try running this here. I do know that we want to return the last row, not the entire 2D array. Looks good. Let's try submitting. And success. So basically, once again, This second approach also runs in O of k square, and then O of k, or this is the space complexity, and this is the time complexity. So the reason why this is k squared is basically the two for loops here, where k is the row index, or the number of rows in kind of that staircase or pyramid, however you want to think about it. And then it's O of k because of our two-dimensional array that we're basically building up here. All right, and so I think that's about it. What I'm just kind of realizing here is actually I think this is for space complexity, it's actually O of k squared. And so that's because of the staircase here. Really, in the worst case, you could argue that it's two-dimensional in nature. And so I guess it would be O of k squared, not O of k, because it's not just a one-dimensional array. It's actually a two-dimensional one. All right, so yeah, I hope that helped a little bit. Feel free to add a comment below, just suggesting any feedback that you have for me, as well as maybe to clarify something for someone else. But yeah, let me know what you want to see next, and feel free to follow for more. All right, thanks for watching.